Hello and welcome to this afternoon's Spaces webinar. Delighted that you're able to join us, and really delighted to welcome Patrick from Edinburgh City Council. Patrick currently heads the delivery of design and project management service for the non-housing operational estate. And Patrick has a long-standing interest in energy and sustainability, with a current focus on addressing construction quality issues, emerging energy performance gap and net zero. This interest resulted in making the case for the adoption of Passive House for new build projects, which is now the City of Edinburgh Council's approach across its operational estate. Patrick has established an informal Passive House delivery forum, currently attended by 8 local authorities across Scotland, while delivering projects to certified Passive House standard. And some authorities are now at very advanced stages of Passive House project delivery. I'm also pleased to welcome not only Spaces people today, but also colleagues from Essex Construction Framework, because we've joined this framework into this webinar. So we've got Essex Best Practice colleagues as well joining us today. Just to make everybody aware, slides will be available after the presentation, and this presentation will be uploaded onto YouTube at some point in the near future. We also ask at the end of the presentation if you'd be kind enough to provide feedback, and there'll be a link provided for that during the presentation itself. What I would ask, and just remind people, the way this webinar jam works is you do need to put your question into the Q&A or chat box, and we will pick those up, and Patrick will then look at those and we will deal with all the questions at the end of the presentation. But please use that opportunity to either put questions in or any thoughts or any ideas that you may have to stimulate a bit more conversation. So over to Patrick, and thank you very much.
Hello, good afternoon, everyone. Okay, let me do the screen share. There we go. Is that working for everyone okay?
Yes.
Wonderful. Okay, right, so I'm going to talk you through our approach, and it's really our methodology as we address net zero across our estate. And as the introduction, our operational estate is really the focus of the discussion, and lots of slides to go through, so I'll be kind of going through them at a fair old rate, and obviously opportunity for questions at the end. So let me see. Our starting point for everything in addressing this was the fact that we looked at dealing with Passive House as our approach to our new build estate. Why Passive House? We came at this from initially the issues over construction quality. Those north of the border will know there was a coal report into an external leaf wall collapse on a PPP, which is our version of PFI school. It was an issue around wall ties and the like, and the construction quality really became an area of focus in Scotland. And Passive House and the checking and the regime around Passive House and the rigour is a contributor to addressing construction quality. It's not everything, it's part of it. Similarly, we were looking at the performance gap. What we were finding is recently delivered schools, and some of this talk will likely focus on schools because that's where a lot of the new build and a lot of our kind of efforts are currently focused. New build schools were demonstrating significant performance gap. That's reported nationally, SIBSE and the like, and we've identified Passive House as one way of addressing that performance gap. And it was likely as much a consequence of the more realistic modelling that the PHPP approach takes for Passive House, and means that you've got a kind of more robust approach and solution, thereby the performance gap is addressed. Obviously, consequences of lower energy consuming buildings, and primarily, and linked to that performance gap, is a comfort standard, making sure we provide comfortable buildings. I'll come to that when we go through one of the pilot studies we're looking at in this presentation. And in Scotland, and I'll have to put things in context, our Scottish Futures Trust, who work alongside Scottish Government in their funding, have set quite exacting targets for energy consumption in new build schools to support funding. 67 kilowatt hours per square metre a year, quite challenging. Where did that come from? It came from them looking at what Passive House was delivering, and albeit they're not saying Passive House, we were already on the road, and when we went on the road of looking at Passive House and they kind of joined us in that journey to some extent, they landed on that quite challenging energy target. And all this helps with our net zero carbon aims. And so we are now also addressing another document which is produced north of the border called the Net Zero Public Sector Building Standard, and that has a lot of aspects of it around energy consumption and moving more into embodied and whole life carbon as well. So that's the new build, and strangely, that's the easy bit. The challenge is the existing estate, and we have 400 heated buildings on our operational estate. We're talking the schools, community centres, care homes, offices, libraries, and such like. And then sitting alongside that, we've got other properties which are kind of they're not directly under our control, but we quite often get involved in works associated with them, the Edinburgh leisure facilities. So there's big opportunity there as well, but big challenges. And another aspect of this is if we're setting targets as a city, there's a requirement to show some leadership. And in doing that, it really got us out of the block very quickly in coming up with how are we going to set out an approach and think about a kind of a methodology for addressing this issue. Just a little bit on dealing with existing buildings. The inverted pyramid on the right captures in decreasing opportunity for reducing energy. If you're building a new building, get the location, orientation and form right, good Passive House stuff. And the fabric element down to appliances, lighting and use. And when you're dealing with an existing building, the ship has sailed for the upper issue where there would be big opportunity like location, orientation and form. But what we've started to look at is really examining that fabric element more than possibly would have happened historically with a lot of energy conservation type activities. There was always an element of it, but we're looking far more aggressively at that, and also building airtightness. Key to this, though, is recognizing you start increasing airtightness and insulation levels, you don't lose the support of the building user, and building comfort goes out the window, if I could use that expression. So important that we keep a mind of user comfort in this. So because we're doing Passive House and we saw the benefit of the PHPP modelling to predict the energy consumption of the building before it's built, we adopted the EnerFit approach as our starting point, EnerFit being the retrofit standard of Passive House, albeit a very aggressive retrofit standard. And initially I was looking at EnerFit, the application of that, but using the model and some step off point where you would decide you're not going to go full EnerFit, you're going to step off at some point where you think it's appropriate to a level to which to take the level of retrofit. But what we ended up doing is actually coming up with a series of options for each building we analysed, and we've called it an EnerFit informed retrofit approach. Apologies for the kind of tongue twister there. But why are we saying that? We're applying the rigour of the EnerFit methodology, but we're not necessarily going to target the low energy that EnerFit is expecting. So it's an EnerFit informed retrofit. We'll typically be doing retrofits. We may do some full EnerFit on some projects. And then another aspect of this worth bearing in mind is there may be a decision to do works in a phased way, doing an elemental approach. This talk is really looking at doing a deep retrofit in one go, but you could see how an elemental approach could work, and we could talk about that if that would be a benefit to people. And our route for this, being a local authority, we do asset management works, our life cycle replacement works. We've been on a kind of increased spend for the last 5-6 years. We actually peaked at spending 48 million on our existing operational estate while it was still up and running in 2019-20 before lockdown, and we've throttled that back a bit, but we've shown we can do quite significant interventions on our estate without closing buildings necessarily. So this was the kind of the vehicle by which we would be looking at delivering any of these retrofits. Just a little bit on asset management type work that we do. We typically would do roofing, we would typically do windows, everything highlighted in yellow. We would not normally be doing wall insulation, underfloor insulation, but we would in the past be doing boilers, replacement, electrical rewires and the like. But now the things that I've got highlighted in yellow are things that we would likely be looking at going forward for buildings, wall insulation, underfloor insulation. If we're going to seal the building, the introduction of mechanical ventilation, heat recovery, or demand controlled extract, and potentially solar shading if we feel we've gone too aggressive with the approach we've taken to the building. So what I'm going to talk you through is our approach, and it's 2 pilot buildings, which we subsequently rolled out to another 10 buildings, but one's a nursery and one's a primary school, and a little bit on our performance weighting methodology. Not too much on that, it's just an approach we took, and I'll explain why when we get there, and something on quality and our next steps. So, taking our 2 buildings, there's an image of each, and I'll say a little bit more about them when we dig deep into each one. One's a nursery building and the other is a primary school. And they're both very different, and we chose them because they're very different, and we started the work we would have to do to inform the PHPP modelling. So we actually did air leakage pressure testing. We physically opened up the fabric to understand the buildup of key parts of the external fabric of the building. We did thermal imaging to understand where thermal bridging was possibly taking place. Insulation U value on-site testing where we could, where conditions allowed, and also just for modelling purposes, on these 2 we did 3D scanning because we didn't have models of the buildings, so that was the kind of approach taken for these. A little bit on, as I said, our EnerPHit informed pilot methodology. What we do is we take that information, we build up the PHPP model, we test that model against the actual performance of the building, then we, as a group, think of suites of interventions of different levels of retrofit and put them through the model and see what we get with the way of energy consumption associated with it. And so it's really an EnerPHit informed retrofit plan, EIRP, which I believe is an expression the Passive House Trust has started to adopt in this context. And then a little bit on our total performance index, our weighting system to inform decision making. And it's all about providing a series of options for an informed investment decision, or to help to inform an investment decision. So the first building, a Victorian stone building, it's in a conservation area, but it's not actually listed itself, so it meant we could play about with it more. But what we were really looking at there is quite a lot of the estate in Edinburgh can be like this, so it's important that we put ourselves through the challenge of addressing one of these as an early pilot. What did we find when we opened it up, did all that testing? Well, no surprises, little or no insulation, U values were poor, air tightness was poor, we were getting a permeability of 13.2 cubic meters per hour per square meter, and identified substantial thermal bridges. So what does that look like as far as heat losses for the building? You could see 40% through the walls, 6% through the floor, ventilation 12, and the window heat loss is 15. So, you're looking at 27, kind of around that area, and then 26% through the roof, and a heat demand of 340 kilowatt hours per square meter per year. If we were looking to go full EnerPhit, do the full thing, the gold standard, you could call it, how far away is this building from that gold standard? And you can see the heat demand, we're 340, we would have to be getting down to less than 25. Air tightness, I'll keep it in air changes per hour, 12.6, we're trying to get down to less than 1. So this building would have a significant journey to go through to get to full EnerPhit. This slide sets out, and apologies, there's a lot on it, sets out the different levels of intervention and what the resulting heat demand modelling was. So what I'll do is this top section here, the next slide kind of zooms in on those and shows the different levels of intervention. The first one starts at do nothing. That's the existing building as we initially modelled it. MEP only, so that was really talking about just putting in a heat pump. Not something you would do, but just to kind of go through the exercise, put in a heat pump and take out the boiler, and then different levels of retrofit through to full EnerPhit. So just focusing on these in a little more detail. The heat pump, we've got our air tightness shown there, but when we got to our kind of start to improve, you can see we're kind of going for internal insulation on the walls, and this is you can see the insulation level starting to increase as you go through the standards. And we've also got the introduction of mechanical ventilation heat recovery once we get to an air tightness of about 3, where there's traditionally a return on that investment. And then the full EnerPhit is a fully certified MVHR unit, more efficient than just a typical one. Thing that's worth drawing your attention to, full EnerPhit, if you're going internal insulation, based on the approach taken, you're talking about potentially 300 millimeters of internal insulation. So that becomes a question in itself. So, there's no kind of clean answer to any of this, even setting the costs aside. So just going back up, for these different levels of intervention, you can see reduction in heat demand, 35%, 64, 88% reduction in heat demand. And some of these, we go from secondary glazing through to triple glazing for the full EnerPhit approach. And as I say here, full EnerPhit could potentially be deemed impractical if you're losing 300 millimeter with the internal wall coming in, you're losing a bit of GIFA in your building. We also did a bit of whole life carbon analysis, and this is really just a summary. I don't really intend going into huge detail. What we did is we looked at it from the point of view of the deeper interventions, introduced greater amount of embodied carbon, and we thought, well, are we actually making the situation worse with this additional embodied carbon? And no, what we proved is that the operational carbon reduction more than offset the additional embodied carbon. So you were seeing over 70% reduction in whole life carbon associated with the deeper interventions. Obviously, the lower level interventions add less embodied carbon, and also the fact you're going from gas to electricity, you're making a step change in your operational carbon anyway. So that would show itself as a similar argument. So we really did the modelling based on the two options that had the greater amount of additional embodied carbon. Running costs, this is where it gets interesting. Now, please bear in mind, this is all based on third quarter 2021 energy figures for gas and electricity. But the overall story, possibly everything's coming towards improving fabric, but there's still some way to go. So the overall story stays broadly the same. When we took out the gas, put in the heat pumps, despite the benefits of the seasonal coefficient of performance of the heat pumps, the mere cost of electricity meant on third quarter 2021 tariffs, you were doubling the running costs, and then you could see the reduction. And this is where I talked earlier about the step-off point. My initial thinking is maybe we do a level of intervention where the step-off point means that our running costs aren't much different. So we've done enough fabric improvement before we deploy the heat pumps. So you're getting into quite deep level of retrofit to be able to do that. But as I say, this all jumps about a little bit with the tariffs that have changed and keep changing as well. And this is the difficult slide actually for people, but possibly explains why we're all in the situation we're in. What this showed was the return on capital associated with this, and it was based on 3% inflation rates and 6% discount rate, and it was based on the tariff at the time. But what this really demonstrates in summary is the return on investment is buttons compared to the level of investment made for these levels of retrofit, and that explains why there hasn't been a huge amount of spend in this area over the years, and because we're now really looking at an investment to deal with carbon rather than an investment to reduce running costs, and it's a different dynamic. So the finance colleagues in your authorities and the like do struggle with this, because normally you're making this kind of level of investment to see a real benefit in reduction in running costs, but in actual fact this is about an investment to deal with carbon. As I say in the bottom statement there will be a return on investment as a global proposition, but on a building by building proposition, not so much. All these graphs, I know some people prefer to see the numbers, so here are the numbers. So down the left we have our different levels of intervention through to full enerfit at the bottom. Our heat demand, as I say, the first one, we do nothing. We just take out the boiler, put in a heat pump. So 340 kilowatt hours per square meter down to 42. And there's a percentage reduction. And this is where it gets quite interesting. And this is where the challenge is for a lot of people. You can see the capital costs climbing quite markedly based on third quarter 2021 figures. I'll have to keep saying from 400,000 up to 1.4 million. But if you were looking at carbon alone, you would say, well, hang on, wait a minute. If I don't do much, I go electric. I've got myself an 87% reduction in CO2 against the baseline. And for this extra £1 million, I'm seeing another 9% improvement. So the isolated carbon argument kind of nearly doesn't work either, but there is a lot of diminishing returns on this carbon side of it, and there's some other aspects of that are worth exploring as well. And it was just something we did as a bit of an exercise. But if we just swap out the boiler for a heat pump, and we did this knowingly, existing buildings are not great or heat pumps aren't great at addressing existing buildings. Heat pumps are fantastic things, but they do have their limitations. So this would definitely deliver your 87% reduction in carbon because you've gone electric. But if you look, you're going to be 3 times the number of heat emitters because of the lower flow temperature of the heat pump. And you really want to be getting that flow temperature down to benefit the coefficient performance of the heat pump and get it down as low as you can. You would have a large heat pump and thermal store, and it nearly becomes a heat pump farm outside. This was the playground of the nursery, so that would be a question. You would have greater impact on the local network in Edinburgh. Varies around the country, but we've pretty much been told a lot of Edinburgh, because it's still a city that's growing, most areas are at or near capacity on the grid. So we have to look at energy reduction before we go electric. And then we've got occupier comfort concerns. If this is still a drafty building, which could have quite quick fluctuation in air movement and temperature, and the kind of slower response to the heat pump system, could be problematic for us as well. So a number of considerations there. And anything you do, it needs analysis and care. The other building is a 60s primary, and as you can see, it has quite a significant glazing to wall ratio. And one of the things we do as part of that testing and opening up and thermal imaging is we also engage with the building user to identify areas of the building that have been problematical operationally from a comfort point of view. And this building, surprise, surprise, summertime overheating was a significant issue. So this has a bearing on the kind of approach and solutions that we would be coming up with. That analysis, not very different for a very different building, but the insulation, not great. So the U values weren't great. The air tightness, 13.2, and thermal bridges everywhere. So, it's a bit of a shame on our construction industry, but we haven't been doing it much better than the Victorians right up to the 60s. And when you look at the performance gap, we still haven't been that great. Where's the heat been going? Building has a different shape. Its form factor is different, but you can see 21% through the roof, 23 through the walls, and the like. And this is 154 kilowatt hours per square meter per year is the heat demand for this building. Again, and as I say, it's a repetitive process, just showing the same approach, same methodology applied to two different buildings, and we've done it for 12 now. But we've got 154. If we wanted to go full EnerFit, you can see to get down to 25, a bit of a journey. And similarly, the air change rate is high at 9.6. You'd be wanting to get down to less than 1. As I say, similar approach, albeit these interventions are building specific. And I'll just go to the next slide to zoom in on these. As you know, we've got the MEP only, which is just take out boiler, put in a heat pump as a starting point. So that's this one here, and different levels of intervention. And what I've put a circle around is, what's different here. The last building was internal wall insulation. Obviously here is the opportunity to go external, not impact on the GIFA, and it's a quicker, simpler approach as well. But the other bit, once we go external wall insulation, we've got the opportunity there to look at reducing that window area. So that's become part of the approach, and the analysis is based on that as well. And we've gone double glazing through to triple glazing as a solution on that. And the MVHR, you see, kicks in when the air change rate's down at 3, albeit we've got a demand-controlled mechanical extract ventilation look on this particular option. And these options are just really what the team sat down and thought, let's model this, let's model that, and see what it turns out like. And we'll get better at this as we go along, and we'll have maybe something that's more targeted, and I'll come to that in a minute. So the whole life carbon analysis, very different buildings, very similar story. The reduction in or the addition of embodied carbon associated with these deeper interventions was more than offset by the reduction in operational carbon. So we've got a kind of around about a 70% reduction overall there. So what's remarkable is such different buildings, and we're kind of seeing the same things, albeit the numbers may be changing, the same patterns emerge. This one, operational running costs, yes, an increase in operational running costs if you took out the boiler, put in a heat pump without improving the fabric, and then it's not till you're getting into these deeper levels of retrofit or ideally full EnerFit, you're seeing a saving. But as I say, based on third quarter 2021 figures. The return on investment, again, just the same. And it does kind of, you do feel when you're doing this and you go from one building to the next and you're seeing the same thing emerge. Why are we doing this analysis every time? But at the moment, we've done it for the first group because we think it's important to see if the patterns that emerge. And it's the same point. It's not a return on investment. It's a carbon reduction investment. Again, looking at the actual numbers, you can see the same pattern again. You've got the 154 reducing to 23 kilowatt hours, and then you can see the reduction in heat demand, up to 85% reduction in heat demand. Cost base at that time, third quarter 2021, was 1.5 million, and then it would be up to 7 million to address that building to full EnerPhit. Just as an indication, we've taken that building further, and I'm not saying we're going to necessarily deliver it to full EnerPhit, but we were asked to for a specific reason. About we got some grant funding. We might step back from it, but that 7 million is more like 12 now, because you've got to add in the thing that figure excluded and always has excluded all the way through is decant. But at the time we've identified decant would be necessary, even with the opportunities to kind of phase wings. By the time you add decant and inflation, you're starting to look at 12, 13 million for full EnerPhit for that primary school. And law of diminishing returns as well, a lot more money spent. But carbon you've dealt with, but you've got issues with running costs, issues with connection to the network, and issues with comfort if you just go for the lowest of the low without a lot of care. Another little comment, because it's a school, it's just worth commenting on. When you do the deeper interventions, this is a kind of a graphical representation on the MEP solutions, but when you go for the deeper interventions, you're starting to address BB 101 on your existing buildings, which in this COVID world of trying to keep windows open and the like, and all the challenges that is about air quality in schools over the winter months, quite a powerful argument for deeper levels of intervention. So it's part of that discussion and decision-making process. This I'll skirt over a little bit, but this is our decision-making tool. It's not to make the decision, it's to kind of offer a little bit of a touchstone for some consistency of decision-making. And we sat in a meeting and we thought, what do we see as the most important issues for us for delivering these kind of solutions? And this was decided at a meeting, put out for consultation, and nobody changed it, which is interesting. But we thought comfort, life cycle carbon, and running costs were the most important issues for us, with capital cost, and then the heritage impact, fabric risk, and then user disruption. I thought user disruption would be challenged, but it wasn't. The reason we gave it such a low score was that disruption would be for 18 months, say, of the life of the building. But how this really works is we look at each particular issue. Some of them we've calculated and analysed, like running costs, so we know which one performs best and which performs worse on running cost. Some we know pretty much whether is what it'll perform like from an overheating thermal comfort point of view. So we give them that kind of index, multiply it by the weighting, add them all up and get a total performance index, just to give a feel for, based on what we think is important, which one comes out best. And based on that, for the nursery building, the level before full EnerPhit came into being slightly the best. But as these figures are so close together, you could say a kind of sensitivity analysis, you would say you don't have to tweak very much to change these numbers about, but it's indicative. But it just shows that the MEP only approach for various issues around comfort and the like gets a particularly low score. So you would, if you were taking that option, you'd have to do it knowingly and give it some real thought. What does that same analysis look like for the primary school? The nature of the building just means that the full EnerPhit came out top based on those weightings. That's not to suggest we're going to be doing EnerPhit across our estate. Wish that we could, but we wouldn't be able to afford it, I expect. So it's an interesting exercise. And when the decision-making process is properly made over more buildings, we will adjust these weightings and to kind of align with the kind of discussions that take place. And then that just means we've got a degree of standardization or a touchstone to revert to as decisions are made on the future buildings. Should we be doing full EnerFit, we would take advantage of the compliance process, the third-party checking that takes place as part of the Passive House EnerFit approach. So, and that's, you know, a recognised process. What we've done here is we've kind of tried to capture, sorry, it's 2 slides, it's 2 images out of a report that I've kind of glued together for this slide, the compliance checking process, which works quite readily when the team that helped develop it are the team you're working with. It'll be more interesting if we apply this with other teams, but it's just part of the challenge, and making sure we don't have a performance gap when we do this kind of work. Our next steps, and so we've taken another 10 properties to this feasibility stage, and we've taken 2 buildings to RIBA stage 2 so far and they were based on some funding we'd secured, looking at full EnerFit, but we're likely going to step back from that. And the 2 buildings we'd taken to that full stage was Brunstane Primary School, Brunstane Primary School, the one you were just talking about, and this one here, which is Lorne, which is a Victorian, very square, in plan building, and quite difficult to treat because it doesn't actually have very city centre, nowhere for decant and the like, so quite problematical. And at the moment we've taken that, but the view is we might step back from that and we'll be looking at that nursery building we were talking about earlier, and possibly we're looking at delivering to a lower standard. So this is us through our pilots, just getting a feel for how things are kind of working out. One thing that has come into bearing, when we started this exercise, there wasn't a lot of guidance on energy targets. That's starting to appear now. They tend to start for domestic properties, but they're moving into other areas. But in Scotland, we have Scottish Futures Trust have their net zero public sector building standard for existing buildings coming out in the next few months. And we have engaged with them to allow them to beta test this standard against our work on these 2 buildings. We take them forward. And that is expected, it's not published yet, but to be targeting 100 kilowatt hours per square meter operational energy. Ours is kind of EUI approach to energy use intensity, not much in it, but you just need careful to be sure we're talking apples with apples. But that would be a starting point for the discussion, and something we'll likely introduce to our kind of methodology for making selection. Truth be told, EnerFit can be very difficult to justify with the costs, and that's what we found since I last did this presentation many months ago, and we kind of expected that to some extent as well. And the other thing to bear in mind is this process, and the fact we're also looking at heat networks and things, has really pushed our colleagues on the kind of asset management side of things on how they're looking at optimizing the estate, because you don't want to be making investments like this in buildings that you think are possibly not going to be on the estate for 20 years' time. A little bit on looking more widely, it's a little bit off-piece for this discussion really, but it's just we've based our approach on heat pumps. Why heat pumps? It's the kind of most recognized available technology that's out there. All these costs, you only expect them to improve as heat pumps become more efficient, able to deliver, Stirling cycle heat pumps and like, able to deliver at lower temperatures, but keep that coefficient of performance. Heat networks, we will certainly, and we've started looking at heat networks, always worried about the driver for heat networks because they do tend to like to keep the high energy buildings as their anchor points, and it kind of maybe makes the business case for reducing energy consumption get a bit confused, but no, heat networks are very much on the agenda. In Scotland, I don't know the rest of the country, but hydrogen is getting a really big push, blue hydrogen. All I'll say, I can talk more about it, bit of a hobby horse, but it's contentious about its efficiency, what it would actually cost, the impact of hydrogen on the environment, the impact on hydrogen and keeping methane hanging around longer in the environment, and the impact of methane as a global warming gas. So there's a lot of issues with hydrogen. But the benefit, and the easy sell benefit, is hydrogen-enabled boilers are on the market. I imagine the commercial side of it will come to the fore as well. And you could just, over the next 20 years, be replacing boilers, and happy days, you've decarbonised if you truly think you've got low carbon hydrogen and it's affordable. So, you know, that's a kind of an interesting one to see. It'd be great if it could happen, but I just don't see it. But what we do see, the no regret approach, is to look at fabric improvements regardless of the heating technology deployed, because all this, you know, even the hydrogen is going to consume electricity. Energy is a precious commodity, if I could call it that, and we need to be more careful about it. And just getting towards the close, the work we're doing with the Passive House Delivery Forum, it's very informal. We just catch up every 6 weeks to talk about what we're doing on the delivery of new build passive house. But of that, 3 other authorities have adopted this methodology, and we're going to pool our data. So they'll be doing about 4 buildings, 3-4 buildings. It means we'll have a pool of 20 buildings being subject to this methodology, and that would contribute greatly to any kind of assessments of it's the overall estate-wide approach, albeit you wouldn't necessarily know which of the options people would take forward. And we've also got numerous wider engagement groups. We've got the Edinburgh Partnership Board, which includes the education sector, universities and the like, and we're looking at a collaborative approach to addressing public buildings. So I'll close there.
Okay, thank you, Patrick. That was excellent. A real lot of information there, and I'm sure there's a lot of people will be taking that away and digesting it, because it's really good to see that something's been done in so much depth, and a lot of science behind your approach. We've got some questions and statements in the box, which I shall read through. They're in the chat only. Jonathan Hill, sorry, says, I can't see that any schools outside of Scotland will ever achieve the DFE's criteria. So there's a viewpoint there. Adrian Morris has come through and said, did you work out the embodied carbon payback period for the upgrade to triple glazing?
No, I recognise that people see triple glazing as a kind of an embodied carbon problem. No, it was holistically looked at in all the interventions. So if I zoom back, if I go back up, where are we? Looking at option 3B and 4A, sitting embedded in them would be, that one's double glazing, this one's triple glazing. So there would be the tweaks. So there, it's embedded. We didn't look at it in isolation, if you like. It was just embedded in all the interventions for the building.
Okay, thank you very much. Just as on a personal note, I noticed your options when you say just put in air source heat pumps. I'm not sure how it works in Scotland, but certainly down here there's government grants that come out, and it's everything's like it's just focused on one area. So it's about getting, say, air source heat pumps fitted. There isn't like a strategy that's gradually getting the fabric ready over a period of time, and then you introduce air source heat pumps. It's like, well, there's money now, we've got to go for it, which kind of from a technical perspective all seems a bit upside down.
It is actually a shame, because I think there will be people who will have bad experiences with air source heat pumps. I'm sitting in a 30s semi-detached house at the moment. If I put in an air source heat pump into this house as it stands, it wouldn't be very clever. And because of I'm doing this, I've got a fair idea of what I would need to do. I've got an idea of what I would love to do, but at least I've got a bit of a sense of at least do this, this, and this before the adoption of air source heat pumps. They are fantastic devices, but their limitations are exposed when you apply them to existing drafty, ill-sealed, poorly insulated buildings.
Yeah, I absolutely agree with you there. Adrian Morris has asked, was EPS external bead insulation okay from a robustness perspective in a school environment?
We haven't gone into that level of detail yet because we're kind of early stage design. But you know, it's like all this stuff. We're testing everything, and the actual specification of the kind of full solutions is still to be determined. So I kind of maybe a bit premature to properly answer that. But okay, we've got to make sure that whatever we do is robust enough for the environment, and we select things with care. You know, a lot of insulation solutions aren't necessarily all they're cracked up to be either. So, you know, we need to be careful about that. So sorry, I haven't really got an answer for that.
That's fine, thank you. Jonathan's asked, what do you think about the UK's attitude towards ventilation in that MVHR is the bottom of the pile?
I don't know that it is, actually. I think what's happened north of the border with COVID was we now have CO2 detectors in every classroom across the country. And that informs the staff about opening windows. And the Scottish government and the educationalists see, we've put our last two secondary schools they're not passive house, but they've got MVHR, you know, the room-based MVHR, not centralized. Yes. And they've been well received. We're a bit kind of hesitant about the room-based units, really, because from a maintenance point of view, they tend not to be, you know, if a room-based unit has a dirty filter or a failed fan, it gets ignored. Where a central unit, a failed fan, the building's suffering, so it gets addressed from a maintenance point of view more quickly. And also when you're trying to deliver a passive house solution, you don't want all the penetrations in the external fabric that room-based units would bring with it and the like. And then you've got the issues about the units are getting quieter. But I think in our world and the COVID kind of world has kind of moved people towards understanding, let's forget about MVHR, mechanical ventilation. It was held up as it wasn't fresh air for a long time, I think, by people, you know, an opening window. And our schools did default to natural ventilation being the solution. And it's kind of proven to be falling short when you get into the kind of situation of COVID conditions in the winter months. And so having the schools that have MVHR are sailing through it, air quality wise and comfort wise. So other things have maybe caused a shift. And I hope that answers the question. But I do recognize if you go back in time, the default was a natural ventilated solution. And I totally understand why, albeit people were maybe starting to push it beyond, say, 7.5 meter deep spaces and things, and it wasn't so effective when you get into deeper plant space. But I hope that answers the question.
Yes, thank you. Steve Rufus, President-elect, has put a question in which I'm going to add something to that, and that is, what is the indicative cost to carry out each assessment? And you probably mentioned this already. Who did you use to do the work for you?
Obviously, it depends on the size of the building, and the cost per square meter goes down the bigger the building, but the cost is higher. And so we did a lot of medium-sized buildings. I would say off the top of my head, for kind of things primary school-ish in size, and this kind of smaller offices, you're into about £35,000 a building. A big chunk of that was actually taken up by doing the scan and the 3D modeling. And then another significant element, because we're doing the air tests, the pressure testing, the like. So there was that, and then the analysis. And our analysis here likely went further than you might do when you get into a situation. What we wanted is a process where we'll be doing them more in-house as well. We've got passive house designers in our in-house team now as well, and it's the same methodology. So we're hoping to get to the position where it just becomes a custom and practice, and those costs will come down. But at the moment, it was an expensive exercise for us to do the 12 buildings that we've done.
Okay, there's I ran these out. Jonathan has put another question. It's a real shame that people have had such bad experiences with heat pumps. Our best advice for commercial buildings, at least, is to use electric boilers to deal with peak loads. The peak loads are one of the elements that are making them so expensive. So that's just I think a comment really.
Yeah, no, I think there is that question, and electric boilers could be one potential way around it. You know, the approach that I know some authorities are doing is they're putting in heat pumps to cope with that 80% of the time when the heat pump is really happy and really effective, and then leaving the boilers to deal with the peak load condition. And yeah, there's more than one way to skin a cat, and that is one potential thought, yes.
Okay, and Michael Jordan has asked, you mentioned that targets have been set to the likes of 67 and 100. I believe that was the figures you mentioned.
Yes.
How are you monitoring that progress?
That will be monitored as part of the funding mechanism. So the way the Scottish Government have framed it is we need to demonstrate that level of consumption and metering the building accordingly, because obviously there's variation in community use, and our schools now have embedded libraries and all other. The police are now in some of our schools, the way we're designing them, and we've got NHS facilities in schools that are currently in design, so they're becoming far more of a community hub. So with sub-metering for the school element, it will be monitored, and the way the funding mechanism works is we pay the capital and they will support us with revenue funding over time. And that revenue funding will be dependent on delivering the 67 for the new builds. And if you're missing that, there's a kind of reduction in the revenue funding. You're penalised to the point where I think you wouldn't get the funding at all if you completely failed. So that's why we're kind of a certified passive house will hit the 67, providing you get certified. But, you know, obviously there's no guarantees with anything. It gives you the strongest crack at it. The retrofit work is a different thing, because we will be funding it as a local authority, and, you know, there's no other source other than where we get opportunities for grant funding and things. So the 100, I don't know how the 100 would be monitored. We will certainly have an interest ourselves because of the running costs associated with it, but there's nothing suggested that there's an external person who will penalise in some way for missing it. So that's the kind of lie of the land for us in that one.
Okay, thank you, Patrick. Well, that's all the questions, you'll be pleased to know. And thank you so much for your time, because I think that's been a really informative presentation. And we finally got there, because you was going to do it at study day, and for various reasons, around strikes and everything else. But it's great to see you doing it. Fiona's now going to just give you an update on next webinar that we've got. And thank you to everyone who's joined and who stayed on as well, because we've got very high numbers today. So that's great. And just those from Essex County Council, the next best practice session I aim to do in person, and that's probably going to be in January. So for those who have joined us from the Essex Construction Framework, that's when that's likely to take place. So that's me finished. Over to you, Fiona. And again, thank you, Patrick.
Thank you so much, Patrick. It's really good. So for next week, we have a webinar on next Thursday at 12:30 p.m. on decarbonisation, net zero and funding sources by David Gilby, Director at Faith and Gould. I have put the link in the chat bar if anyone wants to sign up now, but alternatively, I will put it out when I send out my email later today. So I will now, if you could please tell us what you think of this webinar. I've got the poll on the screen. Thank you. So thank you very much for your time, and we hope to see you again.